Hey, this is Srikant Devarajan once again with the Small Wall Podcast.
Pete, prod's down. Looks like some issue with auth. Any idea?
I know it was tested. I think Jordan did. Or maybe it was auto-deploy. I'm not even sure. Let me hook Ivana.
What? Wait, let me check. Maybe we roll back the last commits? But we do not know which one, Pete. This is not good.
Why is it always like this? We ship fast, but when things break, we have no trail. We need a system that shows us the whole story.
So we built one, not just a dashboard, but a trace graph that tells the full story. We call it ContextOps. Commits, builds, CVEs, deployments, even Slack threads, all stitched together. And on top of that, an AI agent that reads the signals, spots patterns, and recommends where to look next, a recommendation engine. It's all local, it's live, and it shows you not just what happened, but what matters. Let's get into the podcast.
Out in the wilds, where the breeze runs free, I saw you standing, staring at me, a daring grin.
So let me set the context. Like when I started out long back in 80s, 90s, we were writing applications in C and C++. Our logging was very simple. We had few log files. They were easy to read. You just open the log file, you just read it and you saw what was going on and what went wrong, etc. Now, there are logs for every tool, builds, deploys, alerts, chats, everything. All applications generate logs. There's too much of it. Something breaks, and we will be generally clicking around, thinking about what went wrong, looking into our source code, back end, front end, whatnot. And we'll be checking into our too many logs, and we will ask others too. It's very complicated now, and we are not sure what caused it and what to fix. It's not clear anymore. The reality is we have more logs than the source code.
Friends, or at least not enemies. A swirl of laughter and mischief flees. Mocking words and teasing grins. Let's see where this odd tale begins. Friends, or at least not enemies.
What is context ops? Context ops is the practice of capturing, modeling, and visualizing the full context behind software changes across code, builds, vulnerabilities, environments, and conversations. And the purpose of this is make cause, effect, and intent visible. What is that? Cause. See what triggered a change, who made it, and why and when it happened. The effect. Trace how that change move through builds, deployments, and systems. Intent. Understand the purpose behind the change. And this is called as context ops. So now let's look at this in action. Let us assume that there is a CVE and we need to know the blast radius, right? So this tool that I have will give you a complete trace. For example, it starts from an engineer who just did the commit of an artifact and he was working on the bug here, you can see, and this is the actual affected component running in an environment. So in this, if you see, you can see who it is, and we can spot when was it is, for what it is, and which component is affected here, and where it is running exactly. So you can really trace through this. This is a trace for commits. Here you can see the engineer who just went committed this for a build, and this is the artifact that this affected, and this is the actual component that it impacted, and this is running in this environment. So how it works? We have sources, we ingest all our logs, and there is an AI agent which will understand it and read the relationship. And we store this in Neo4j database, and there is front end that will give you the result. Explain you the design. We ingest data from tools team already use: Git, CI pipelines, chat, security feeds, and deployment logs. The AI agent watches the stream of events and tracks what happened and what followed. It lays things out as a map. Each step, a change, a build, a message, becomes a dot. The system links those dots, showing how one step leads to the next. It also suggests where to look, which changes tied to a risk, which bill to check, and where the teams talked about it. So instead of guessing, you really trace what happened. So now let's quickly jump into the demonstration of this app. And I think you would understand once you start looking at the demo.
If your name's on the pink slip, you are in the small wall. If they cut, no goodbye, you are in the small wall.
So here we are with the application, what I've been talking about, AI-driven context ops. What does it mean and what does it offer? It offers you clarity over chaos behind dashboards. These dashboards that we have, right? We have plenty of dashboards, and some of them are overloaded, in my opinion, and it is worse than an airport dashboard where you see so many things happening around, so many planes comes and goes. Right? It's so huge. It's very hard to keep track of anything and how to relate. Right? For example, in an airline scenario, right? You see when the plane will arrive, but you don't have info there to say like where it is right now, or let's say some flight is delayed and you need to understand the reason for that. You can't. It's very hard, right? You cannot drill down because you're just going to have a screen to say that flight delayed and you don't have any further information on that. So these dashboards, right, what we have these days, in especially in CI/CD or maintenance, the world that we live in, right? Too much info that we have, and we already spoke about our logs. Uh, we have more logs than our source code itself. So to deal this, right, we need to streamline this and make this more intelligent, more useful to us, and we can use AI to do these things and give you a very clean report context. It can bring context to our CI/CD. So to start with, I have on the left side, you see all the features that this app has right now. Of course, I can add more, but not now, maybe soon. And on the right side is the actual thing, and we'll talk about each one of them. So the first one we're going to see is the blast radius. So to understand what a blast radius is, you need to understand what a CVE is. So what is a CVE? A CVE is a public list of known software problem that could be used by the hackers. It stands for common vulnerabilities and exposures. When someone finds a weakness in a tool or a library, it gets a CVE number. That number helps the rest of us to know there is a risk and that it needs to be checked and fixed immediately in some cases. The problem is not over just by understanding the CVE. Blast radius is a part of a system that gets affected when something fails. It measures how far the impact spreads across the builds, deployments, or services. The bigger the blast radius means more areas are at risk. Smaller the blast area means the problem is easier to control. So in short, a blast radius is the total area of a system affected when failure happens. Now coming to our context ops, maps the full blast radius. It shows where the problem started, what steps it moved through, and where it's living today. It does not just collect logs, it shows the real of the problem, so you know exactly what needs your attention. It gives you clarity when everything else feels like noise. So now let's look at all the CVEs here. As you can see that I have a list of all the CVEs. We can go way back, and some of them are imported from a public website. Some of them are imported from a public website. So, and it has been automatically categorized as critical, high, medium, low. So these are some of the highs and these are some of the lows, and that could be some unknowns too here. Let's not go there, but let's start with critical. So when you go and click on this, let's take something. Let's take the billing engine, the service that's got an issue, right? It has identified that this vulnerability is there in the service called billing engine. So when you drill down into this, right, you see the path of what's happening really there and who introduced it into the system. So to start with, we have a developer here, Sophia, an imaginary name. Nobody is by that name here. Sophia has committed something to the billing engine, the code base or whatever it is. I call it as an artifact. So she had committed something here and that has reached all the way to the production. And she was actually working on the bug here, that is a bug which is being identified that it matches the CVEs. So you can move it as you like, as you see it's near 4J. So you can see the complete path and the flow of it. So here you can see the summary here on this side where it says a CV is linked to a vulnerable artifact, and the artifact was built from a commit, and this commit was made by a developer, Sophia, we know the name, and this artifact is running in the build engine in the production environment. So as you can see, that it can trace through everything, and it will also tell you when was this deployed, and it will automatically give you the path of the events that happened. The way it works is we go and ingest all the logs that are out there in the world, and we try to see some sense into it. So this also includes a recommendation engine. It's not over here. So the recommendation engine is going to read something from this, and it is going to give you some good recommendation saying, hey, this is what you need to do. Let's say that there is a huge problem and you don't know what to do with it, and this recommendation engine will offer you some advice, and it might not be 100% because we humans are more experienced at this moment than this. So we can just use this as a reference. So it clearly says that based on CVID provided, the issue related to critical signal vulnerabilities, it identifies the engine straight away, and it also tell you the commit, and it names the developer who is responsible for it. It clearly says that it was deployed on this date to the production environment of a service called billing engine. It also gives you some good advice. Considering zero critical, it is essential to take immediate action. The immediate actions are stop new deployments, modifications to the affected service until the issue is resolved. This will help prevent further exposure. And it reviews the commit history associated with vulnerable version, and it gives you a lot of advice. You can read it, I think. And it will also tell you to communicate urgently with other DevSecOps teams immediately, saying that this component has got the vulnerability. If possible, gather additional information from the development team created and affected this artifact. Call the developer and ask what did you really implement, etc. And it gives you a lot of steps to do. So this is a simple recommendation engine. It goes and reads the logs and gives you some advice where you can on, right? Because when something like this happens, right, we need immediate action, and most of us will go into a meeting probably, and we will be saying A, B, and C and D. But this kind of reports will help somebody in a meeting to read it and say, okay, this is the plan of action that we are going to do. Just a recommendation. So let me take one more thing here. Let me go to something easier, something medium. Now we saw something critical. There is an issue here in the inventory manager component. And similarly, we are going to know severity is medium. And it says which artifact it is. It says inventory manager, it's commit number, commit ID. Who was the engineer who was working on this at that time? Zane. And when was this deployed? It says you very clearly. And similarly, when I zoom to this and drag things around, right? So you can see that Zane did this commit to this artifact called the inventory manager fixing a bug CVE that is linked to it, not bug, I'm sorry. And the inventory manager is the prod component that's got affected. So it is in prod, but it is medium. So we are going to run our recommendation engine here again and see what is the result, the report that it's going to give you. It clearly gives you the CV number and other information, and it also says based on the severe deployment, it is essential to address this vulnerability as soon as possible. As it's a medium severity issue, immediate action is recommended to reduce any, yeah, obviously, and immediate patching. It says first step is to apply necessary patches provided by the developer Zane for the CVE. So it is now asking the engineer to give the an alternative remedy to deal this. So you can read Zane and say, Zane, this is what happened. Do you want to do it to your source code? Check it out, apply it, redeploy it probably. And it is also recommending you to do a system audit. It says this is the audit you need to do, ensure things are open. It is recommending you to do a communication plan and ongoing monitoring, whatnot, right? This is again a recommendation engine. So this gives you a lot of things to do. And let's look at one more to go to the low. The low one is very simple. Let's look at this garden issue in the API gateway. Similarly, there is an engineer, Sophia, once again. This is the commit that is happening, and this is happening only in dev area. So let's go into this. Again, do the recommendation one more round. And the LLM is running now to think through the logs and reading it. And CV's reporter severity, the risk of vulnerability is considered minimal. However, it is advisable to take appropriate action. Update the software artifacts in CVE is found in the version. First step to update the newer version, right? It's just giving you. And it is also saying that monitor development environment. As CV is detected in devs environment services, it is important to show up. So it is saying this, it is enough that if you look into your dev, and at the end it says, well, the severity of CV is reported low, taking proactive measures will help us in the end, right? So these things can be reviewed in errors to say that, hey, you did this and this is there. So you can next update, you can make sure that these things are addressed. So very straightforward help here. And to close it. So this is what this blast radius tool is all about. All these things are after ingesting huge amount of logs that we will talk about. Next option we are going to see is the timeline component. The timeline component is very simple. I'm just drawing all the incidents that happened. Take, for example, I took builds. What are the CVEs that came in? Developer commits, deployments that happened, and even Slack messages. Like, what did they talk about this incident? Is there anything that we need to hear about, right? So let me zoom it a little bit. As you can see that at 2 o'clock or whatever, 3:20 time, right? We have a CV here, the same screen here. It comes up and somebody can look at it and audit it. And it's a low priority. So you can see it here. And these are the, you can see who did it, commits, basically by whom. And we can give more info here. We can open a bigger window and say that this happened really. We can drill down deep into it if needed. And these are the deployments that happened and who and where it was deployed to prod. This is deployed to dev, right? We can keep track of these things and we can take a report. And this is the chats, right? If some vulnerability or something happened, is there anything in the chat that we need to record? Because we engineers talk a lot on the chat, saying that we can do this, we can do that, and we might have some important info there. So those things are also read or recorded, and it is used here for our reporting. But I didn't show all the chats because you might have something that you shouldn't be seeing. So we need to clean that up a little bit and show things that are really important here. So this is my activity timeline view. We can go on. And last but not the least comes our social feed. These are the commits made by each engineer. It's there for everyone to have a look at it, because right now we are not aware. We need to go and search somewhere else, right? But here at one dashboard you see here, you see all my engineers here. You can see all their comments. So let's pick one, right? Take this Noah, right? He's done 1, 2, 3, 4, 5, 6 commits here. And you can drill down into this and trace it. Like similarly, how we traced our CVEs, right? We can see developer Noah and commit to this. He did one build and he did it to the inventory manager component. This is the artifact, and this is the module, bigger module that is running in the dev environment. So you can see the trace of the whole thing. And you can choose some other. So we'll take Sophia, whose name has been coming up. Similarly, you can see, and this is happening in staging. She did something to Kafka stream ingester to staging. You know that who is working on what. And these tools can be like used in various ways that we can change this to a, a gamification to say that commits, for example, or you can pick up skill sets of individuals out of this to know that okay, somebody is, if you take Sophia, she's working on something like an email sender or Kafka related things, right? Billing energy, right? She can be the special individual who understands that engine. We know who has like worked more on the billing engine, for example. So we know that is the billing engine expert is Sophia, right? So we can come to those kind of relations here pretty easily. And these are the three components that I did. So next, let's jump to the source code quickly. So let's start with our log. Let me close all the windows. And let's begin with our logs here. So I'm going to open up these logs. I go and read all the available logs there completely and build a structure around it, right? Because we cannot ingest everything. So we need to have some intelligence and ingest something, right? So there's a structure here. And you can see here, for example, let me go to the top message here. Let's take starting with this CI build. So this is the build that is happening, and there is a build ID that is ingested, and that is commit the last commit. It is here. It is holding the status also, and which artifact that it is affecting time, like when did it happen and how long it was. 310 seconds probably. Mm. Similarly, you can take another event, deploy like event that happened, and similarly who deployed it and which cloud region it was deployed. So I'm giving you some very simple examples here, and there is a lot of things there. So we have deploy events, we have CI builds, we have CVEs that I was talking about, where this is the ID and these things are available online. So you can go and read about them. Study fact that it affected, and what's kind of how important severity it is, and what's the risk score on it. Blah, it's got a lot of information that I ingest. And all these records are inserted into a Neo4j backend. Once this is ingested, I have an ingester here that is going to do all this. And this is where I am ingesting it. And then I'm going to close this. We have an API endpoint where you got a lot of APIs that I expose. For example, you need all the engineers, right? This will get you all the engineers who are working on the project. And this is my social feed that we saw here. I call it like it's thing Facebook like thing where you got all your activities there of every individual in the team, right? This API will do that exactly. Same here. We saw the events, timeline events. Go up a little bit. Timeline. You can see the timeline events. So these are the timeline events that trace a CVE and simple APIs. And I built it quickly. This is some of the handlers that I use for Neo4j. Configuration is here. I am now explaining the LLM, teaching it to understand who are my engineers and how a CVE it looks, etc., etc. The LLM is being trained here a little bit, and then we have our agent that is doing the reasoner. I call it as the reasoner. It gives you the reason why it happened. Sample is being trained here, and then we get the recommendation. So let me go into that. This is the recommendation engine that uses Olama. So here, like continuing on the reasoner prompt, right? This is where I heard that the prompt that will really do the job. So we can rewrite this in a way you want to rewrite. But I tried writing this many occasions because sometimes it hallucinates. So you will have to be very careful about hallucinating. Sometimes it will hallucinate. And secondly, if you use something like OpenAI, it will be much more efficient. And OpenAI is expensive. Remember that part. Uh, So here is the prompt here. As you can see, we are clearly saying that you are a DevOps reasoning agent. It's not an engineer. It's a reasoning agent. Analyze CV completely and give me everything in that. So it does it and ensuring that everything is accurate here. So this is my source code. So hope you enjoyed this application. So with that, we come to an end of this long podcast. Hope you enjoyed this application. I think there is a lot of things that we can change in CI/CD with agentic AI. We just need to think of good ideas and we need to implement it. And it is not very hard in this ecosystem that we live in. I encourage you to write more apps like this and, of course, share it across the world so that everybody can benefit from it. And please subscribe to my channel, click on the like button, share it, do whatever you want. I have about 25 subscribers now. Hey, so please subscribe to my channel and let's see how it goes. Until next agentic AI application, this is Srikant signing off.
You are in the small wall. You are in the small wall. If your name's on the pink slip, you are in the small wall. If they cut, no goodbye, you are in the small wall. If your patch stopped working, you are in the small wall. If security walks first, you are in the small wall. 난 그때 보라고 이슈를 이대다 이대다 난 그때 보라고 이슈를 이대다 이대다. If your weekend won't last, you are in the small wall. If the third line's fake, you are in the small wall.